Chemical reactions. Let us now understand chemical reactions of carboxylic acid. The study of chemical reactions is divided into four parts. The first one is reaction involving cleavage of OH bond. The second one is reaction involving COOH group. The third one is reaction involving cleavage of COH bond. And the last one is substitution reaction in the hydrocarbon part. Click on the corresponding buttons to learn more. Let us now understand reactions involving cleavage of OH bond. Carboxylic acid-like alcohols evolve hydrogen with electropositive metals and from salt with alkalis similar to phenols. However, unlike phenols, they react with weaker bases such as carbonates and hydrogen carbonates to evolve carbon dioxide. Consider the reaction 2R single bond COOH plus 2Na gives 2R single bond COO minus Na plus H2. And also the reaction RCOOH plus NaOH gives 2R single bond COO minus Na plus H2O. And also the reaction R single bond COOH plus NaHCO3 gives R single bond COO minus Na plus H2O plus CO2. Text. This reaction is used to detect the presence of carboxyl group in an organic compound. Reactions involving cleavage of OH bond. Acidity. Reaction with metals and alkalis. Carboxylic acid dissociate in water to give resonance stabilized carboxylate anions and hydronium ion. Consider the reaction RC double bond O OH plus H2O reversible H3O plus RC double bond O single bond O minus, which is stabilized by resonance effect. For the above reaction, K equilibrium is equals to concentration of H3O plus multiplied by concentration of RCOO minus upon concentration of H2O multiplied by concentration of RCOOH, where Ka equals to K equilibrium into concentration of H2O, which is equals to concentration of H3O plus multiplied by concentration of RCOO minus upon concentration of RCOOH, where K equilibrium is equilibrium constant and Ka is the acid dissociation constant. For convenience, the strength of an acid is generally indicated by its pKa value rather than its Ka value. Reactions involving cleavage of COH bond. Let us now understand reaction involving cleavage of COH bond. The first one is formation of anhydride. Carboxylic acid on heating with mineral acids such as H2SO4 or with P2O5 give corresponding anhydride. For example, the reaction CS3 single bond C double bond O single bond OH plus CS3 single bond C double bond O single bond OH in presence of H plus then heat or P2O5 then heat gives CS3 single bond C double bond O single bond O single bond C double bond O single bond CS3, which is known as ethanoic anhydride. Esterification reaction. Carboxylic acids are esterified with alcohols or phenols in the presence of a mineral acid such as concentrated H2SO4 or HCl gas as a catalyst. For example, the reaction R single bond COOH plus R-OH reversible in presence of H plus gives R single bond COOR plus H2O, where RCOOR is ester. The third one is reactions with PCl5, PCl3 and SOCl2. The hydroxyl group of carboxylic acid behaves like that of alcohols and easily replaced by chlorine atom on treating with PCl5, PCl3 or SOCl2. Consider the reaction RCOOH plus PCl5 reversible RCOCl plus PCl3 plus HCl, and also the reaction 3 times RCOOH plus PCl3 reversible gives 3RCOCl plus H3PO3. And finally the reaction RCOOH plus SOCl2 reversible RCOCl plus SO2 plus HCl. Thionyl chloride, that is SOCl2, is preferred because the other two products are gaseous and escape the reaction mixture, making the purification of the products easier. The fourth one is reaction with ammonia. Carboxylic acids react with ammonia to give ammonium salt, which on further heating at high temperature gives amide. For example, the reaction CS3COOH plus NH3 reversible CS3COO minus NH4 plus, which on heating gives CS3CONH2, which is known as acetamide. And also the reaction C6H5COOH plus NH3 reversible C6H5COONH4 on heating gives C6H5CONH2, which is known as benzamide. And also the reaction C6H4COOH at ortho position plus 2NH3 gives C6H4COO minus NH4 plus whole twice at ortho position on heating gives C6H4CONH2 whole twice at ortho position, known as phthalimide, which on strong heating gives C6H4C double bond O NH single bond C double bond O plus NH3, where C6H4C double bond O NH single bond C double bond O is known as phthalimide. Let us now understand reactions involving COOH group. The first one is reduction reaction. COOH can be reduced to CS2OH by LiAlH4, that is lithium aluminium hydride, and the second one is B2H6, that is diborane. Consider the reaction R single bond COOH in presence of LiAlH4 or B2H6, which on further hydrolysis gives R single bond CS2OH. Text: NaBH4, that is sodium borohydride, does not reduce COOH to CS2OH group. LiAlH4 and B2H6 are used in presence of H3O+. Decarboxylation. D means to remove and carboxyl means COO part. So decarboxylation means to remove COOH part of a carboxylic acid in the form of CO2. Let us take a carboxylic acid, that is RCOOH. Let us add NaOH and CaO in the ratio 1:3. If we heat the solution, then we find CO2 gas escaping out. The reaction taking place is R single bond COOH plus NaOH gives R single bond COONA, which on treating with calcium oxide gives RH plus Na2CO3. Text: alkali metal salt of carboxylic acid also undergo decarboxylation on electrolysis of their aqueous solutions and form hydrocarbons having twice the number of carbon atoms present in the alkyl group of the acid. The reaction is known as coal-base electrolysis. Substitution reactions in the hydrocarbon part. Let us now understand substitution reactions in the hydrocarbon part. The first one is halogenation reaction. First, let us understand what are alpha carbons. Let us take CS3CS2CS2COOH, that is butanoic acid. Let us number carbon atoms from right to left. That is CS3CS2CS2COOH. So carbon atom at one position adjacent to carbon atom at first position is beta carbon. Let us treat carboxylic acid having alpha carbon with aqueous halogen in presence of red phosphorus. Consider the reaction R single bond CS2 single bond COOH in presence of X2 or red phosphorus, or in presence of H2O gives R single bond CH single bond X single bond COOH, which is known as alpha halo carboxylic acid. And also the reaction CH3 single bond CS2 single bond COOH in presence of Br2 in red phosphorus and on further hydrolysis gives CH3 single bond CHBr single bond COOH, which is known as 2-bromo-propanoic acid. Making alpha halocarboxylic acids from carboxylic acid is Hell-Volhard-Zelinsky reaction. The second one is ring substitution. COOH group is a deactivating group. Observe that at meta position, that is position 3 and 5, we have high electron density. Hence, COOH is a meta-directing group. As COOH is a deactivating group, hence it undergoes electrophilic substitution at meta position. The third one is Friedel-Crafts reaction. Consider the reaction C6H5COOH in presence of concentrated HNO3 gives C6H4COOH and NO2 at meta position, which is known as meta-nitrobenzoic acid. Hence, concentrated HNO3 plus concentrated H2SO4 generates NO2 plus and HSO4 minus, where Na2 plus is an electrophile, and H getting substituted by Na2 plus, hence it is electrophilic substitution reaction. Text: consider the reaction C6H5COOH in presence of Br2 or FeBr3 gives meta-bromobenzoic acid, where FeBr3 is an acid.